Solving trig equations with trig identities. We're going to do another example where we are solving a trig equation that involves some of the identities that we've learned. Okay, so you're going to need to remember all of your trig identities or refer to them and be able to find them quickly. All right, so this says solve the cosine of 2 theta. So now we have a double angle, so I should immediately start thinking, well, what are my double angle trig identities? Okay. Cosine of 2 theta plus 3 equals 5 cos theta. All right, if I can get this in terms of maybe a sine or cosine, preferably cosine, then that would be great, but I know that, okay, if I can get this in terms of cosine squared, then I'll be able to solve this probably and create another quadratic, possibly. Okay, all right, and this angle must be in between the interval from 0 to 2 pi. So let's think about cosine of 2 theta. What double angle identity involving the cosine of 2 theta has a cosine squared in it? Okay, well, I know that this would be 2 cosine squared theta, okay, minus 1. All right, and we've talked about this before. So if I use this and replace cosine of 2 theta with 2 cosine squared theta minus 1, I should end up with something very similar to what I've done in the past two examples. Alright, so let's try that. 2 cosine squared theta minus 1 plus 3 is equal to 5 cos theta. Let's bring everything to one side. 2 cosine squared theta, that becomes a plus 2. Let's bring that 5 cosine theta over, and we end up with this statement. All right, now let's factor it. Okay, 2 cosine theta, and well, 2 cosine theta and cosine theta. Those are my my options there. I have a 2 and a 1. That's a 5, so the 2 is probably going to be over here. 2, 1. Since that's a plus, I'm going to be adding, or sorry, these have to be the same, and that's negative, so that would be negative. Okay. And so now we can use our zero product property and say if this factor is 0, then this statement is true. If this factor is 0, this statement is true. So let's set 2 cosine of theta minus 1 equal to 0, or cosine of theta is equal to, minus 2 is equal to 0. Okay. Solve this side, I get cosine of theta equal to 1 over 2. And this side is equal to cosine of theta equals 2. Okay, let's think about this. Cosine of theta is equal to 1/2. Where is the cosine of theta equal to 1/2 on my unit circle? Right there, the x value is going to be 1/2. So I know that the cosine of 60 is 1/2, so theta must be pi over 3 for that angle. Then that angle would be 6 pi over 3 minus 1, so I would have 5 pi over 3. Okay, what about over here? At what location on the unit circle will the x value be 2? Am I ever going to have a place where the x value is going to be 2? Where's the x value 2? Okay. Am I ever going to have a place where the x value is going to be 2? No, it does not exist. It's outside my unit circle, so there is no solution here. Okay? There's no solution, so the only two answers that will work, the only two angles that will make this statement true are when this factor goes to 0. So we say our solution set is the answers that are right here, pi over 3 and 5 pi over 3. Okay? So those are my solutions for this statement to be true. All right? Fairly straightforward. I think you guys can do it. Obviously, you know, you'll probably see some harder questions in your homework, but I think you guys can use this to help you. All right, let's do the last example. And this one is solving a trig equation by using a graph. Okay, and if it's too hard to graph by hand, then graph it on your calculator and do it. Okay, but whenever possible, try to know how to do it algebraically. Okay. All right, let's take a look at the question. It says solve 5 sine of x plus x equals 3, and I actually didn't write down the sorry. Solve 5 sine of x plus x equals 3. Okay, what values of x will make the statement true? Well, obviously, this looks pretty complicated because there is no trig function here. Okay, if I tried to solve this algebraically, I'd probably get nowhere. Okay, it would just become very messy. So what I'll do is I'll graph this on my calculator. Okay, and the way you graph this on your calculator is you're going to graph the left side and you're going to graph the right side, and when you graph it on your calculator, you're really going to graph this. Okay, you're graphing one function, and then you're graphing another function that looks like this. And then wherever, since we're looking for the x values when the y value here is the same as the y value here, we're looking for when this function will cross with this function, and then we look for the corresponding x values. Okay, so graph this side on your calculator, graph this side on your calculator. Please make sure that you are in the correct units. Okay, so in this case, probably you'd want this to be in radians. Okay, since we have a sine of x, but whichever form is fine. If you had it in degrees, you'd just have to write it in degrees. Okay, but let me just draw a quick sketch here since I don't have a calculator app on this computer. If I were to graph this, or on my calculator, I would get something that looks like this. Okay, I would end up with this kind of function here, and then if I were to graph, and that would be the graph of this. Okay, 5 sine of x plus x would look something like this. Okay, and if I were to graph y equals 3, okay, I would have 3 would actually look something like this, and it would be a horizontal line that cuts across like that. Okay, so this would be y equals 3, and this function would be y equals 5 sine of x plus x. Alright, here's my x-axis, here's my y-axis, and so you can see that I have 3 points of intersection. Okay, so you'd have to use your intersect function. Okay, and you're actually looking for what this x value is, what this x value is, okay, and what this x value is. That's what we are asked to find when we say solve, right? So at these 3 points, this line 3 is the same as whatever the y value is on this function. Okay, and if you did this on your calculator, you would get x would be equal to 0.52, 3.18, and 5.71. Okay, so you should be able to find 3 points. Okay, and since they don't identify a range or an interval, you can solve this for all x values, and so my solution set would be 0.52, 3.18, and 5.71. All right.